I'm going to try and explain to you where the formula for law of cosines comes from. But before I do that, I want you to know that this is like calculus level difficulty, and you're not expected to know this, and you're probably not going to understand this. So don't get frustrated. It's just more for my own fun. I like trying to explain this, but it's really for those of you that like to know where formulas come from. And it's also a good practice for later on down the road. A lot of you are going to be in calculus someday. And like I said before, the most important thing from geometry, as far as what you're going to use later in your high school career, is trigonometry. And this is some complicated trigonometry. So this is a look at a couple things that you're going to see later on down the road. So maybe some of this will stick in your brain and it'll be easier when you do actually have to know it. So to explain to you where the formula is derived from, you have to know what a trig identity is. And there's a lot of them. It's just like basically shortcuts when you're trying to solve algebraic problems with trigonomic functions in it, like sine, cosine, and tangent. Some of the combinations of sine, cosine, and tangent are equal to, say, like 1. So here's one of them. If you take the sine of A and add it to the cosine of A, and you square those two numbers, right? Remember, sine of A, sine of, say, 30 degrees is 0.5. So if you're to square 0.5, that'd be 0.25. So sine of A is just a decimal, and you can square a decimal. So that's all they're doing. They're taking sine of A and squaring it and adding it to cosine of A and squaring it and saying that it equals 1 every single time. And that's true. So that's your trig identity right there, but it's actually written like this. When you square the sine of a angle, you actually write the exponent 2 right after the sine. You don't put the whole thing in parentheses and then write the exponent. So these mean the exact same thing, but it's always written like this. All right, so when I get into explaining where the formula comes from, at one point you're going to see sine squared A plus cosine squared A, and I'm going to substitute that out for a 1. So this is just explaining to you why I'm going to do that later. So where does this trig identity come from? Well, we start with a right triangle the same way that we've been doing them here, where little a is the side across from A, and so on and so forth. So if you take sine of A, SOHCAHTOA, that's A over B. So that's what I did here. Sine of A is A over B. This is nothing new. You guys should know SOHCAHTOA. Cosine of A is C over B. There's nothing super complicated right now. Now we're going to square both of these. So we're going to square both sides of this equation. That means everything's going to get squared. Sine A is going to get squared. A is going to get squared. B is going to get squared. Same with cosine. We're going to square all that. Got to write my little exponent on cosine there. So cosine squared A is equal to C squared over B squared. All we did was square this and square that. Now we're going to add these two together. So we're going to say sine squared A plus cosine squared A is equal to this fraction plus that fraction, A squared over B squared plus C squared over B squared, because hopefully it's following logically for you so far. Sine squared A is equal to A squared over B squared, and cosine squared A is equal to C squared over B squared. So if you add those two together, you add those two fractions together. Now we're going to simplify this fraction. This is just adding fractions together that already have a common denominator. It'd be like 2/4 plus 3/4 is equal to 5/4. All right, if you're adding fractions with common denominators, you turn it into one fraction with the same denominator. You don't add the denominators, you only add the numerators. So that's what this next line is. We combine the denominators together just like we combine the 4's together, and we just make one fraction with a b squared denominator, and then we add our numerators. Well, in here, our numerators were like terms, so I turned it into a 5. Here, they're not like terms, so I'm just going to leave them a squared and b squared. Now, here, this is the kind of cool part. What is b squared? B squared is a squared plus c squared because of the Pythagorean theorem. Pythagorean theorem says square your two legs, add them together, and that's your hypotenuse squared. So because of the Pythagorean theorem, b squared is equal to a squared plus c squared. Well, that means a squared plus c squared, I'm just going to make it a b squared, because that's what b squared is equal to. B squared, because of the Pythagorean theorem, is equal to a squared plus c squared. So instead of having a squared plus b squared in our numerator, I'm just going to make it a b squared, because of the Pythagorean theorem. So now we have the same numerator and the same denominator. That reduces to 1. So there you go. Sine squared a plus cosine squared a is equal to 1. These two fractions, when you square them and add them together, it reduces to 1. So that's where that trig identity comes from. Now, we'll use that in this formula, which is going to get a little bit crazy. We're going to start off with the same triangle that we've been using all week, a triangle that's not a right triangle with the little a across from angle A and so on and so forth. Now I'm going to draw in the height and make it perpendicular so we can start using SOHCAHTOA just like we did for law of sines. So that's going to be a right angle. That's going to be H, and we're going to have two right triangles now. So I'm going to work with the triangle on the left, this triangle over here, and just focus on this part right here. This is when I explained how to come up with the law of sines, we did sine of A. Well, now this is law of cosine, so we're going to do cosine of A. Cosine of A is, I forgot something here. When I connected my height to the bottom, I'm going to call that point D. So that adds a fourth point there. All right, so cosine of A is the side AD over the side B. SOHCAHTOA, adjacent over hypotenuse. So cosine of A is AD over B. All right, and then we want it in terms of, we want to solve for AD, so we're going to multiply B to the other side. We're going to get B times cosine A is equal to AD. All right, now this is a little bit complicated. You're subtracting both sides from C. Now that works. Think if you have an equation that the left-hand side is equal to the right-hand side, which is what we have here, but let me just give you something simple like 4 is equal to 4. All right, we could subtract both sides from a number and that our equation is still going to be equal. Like, for example, 7. Say we wanted to take both sides away from 7. We'd have 7 minus 4 on the left and 7 minus 4 on the right, and we'd end up with 3 equals 3. So that same concept of subtraction with our equations is what we're doing in this step here. We're subtracting both sides from C instead of 7 that I just made up. And the reason we're doing that is because this bottom of the triangle, the whole bottom of the triangle was C. Remember, the side opposite of angle C is side C. We have AD. If we take that portion AD away from C, we're just left with DB. That's all that's left. So that's what we did here. We did C minus AD, the whole bottom minus part of the bottom, and we're just left with that much over here, which is the side DB. So on the right-hand side, C minus AD simplifies to DB. On the left-hand side, C minus B cosine A doesn't simplify, so we just leave it as that. All right, so that's one thing. We've got DB defined. And that's what we want, because we're eventually going to use this triangle on the right to come up with the formula. So we want to define the bottom leg and the height in terms of cosine. So now we're going to define the height in terms of cosine. I did this over here, actually in terms of sine, sorry, because that's where our trig identity is going to come in. But just go with me for a second. So sine of A. Sine of A is SOHCAHTOA, opposite over hypotenuse. So sine of A is H over B. Now we want this in terms of H, so we multiply B to the other side, and we get B sine A is equal to H. So now we have, on the triangle on the right, we've defined dB in terms of a trigonomic function, and we've defined H in terms of a trigonomic function, just by using SOHCAHTOA and a little bit of algebra. All right, now we're going to take Pythagorean theorem. A squared in this triangle on the right is the hypotenuse. So A squared is equal to the two legs squared added together. So that's what I have here. A squared is equal to H squared, and I called that C, which is incorrect because C is the whole bottom. It's just dB. So A squared, right here, this triangle on the right, A squared is the hypotenuse, is equal to this squared plus that squared. This is dB and this is h. So we get a squared is equal to h squared plus db squared. That's just simple Pythagorean theorem on the triangle on the right. But we've already just defined db as this, and we've defined h as b sine a. So now we're going to substitute those in. So for h, we're going to have b sine a, the whole thing squared, because that's what h is equal to. And for db squared, we're going to put in the c minus b cosine a and square the whole thing. Now when you square b sine a squared, you're just squaring each one of them individually. So it's b squared and sine a squared. When you square this, now that's the FOIL method. That's distributing. That's like saying c minus b cosine a times c minus b cosine a. And you would do c times c times cosine a, and then you would do b cosine a times c and b cosine a times b cosine a. And this is what you get. C times c is c squared. C times b cosine a and b cosine a times c, you get two of them. So we have 2 c times b cosine a. And then this last term would be squared. So b squared cosine a squared. All right, maybe that wasn't showing up. Basically, when you square this, it turns into all of this because of the FOIL method, because you're multiplying that times that, and this times this, and then that times that, and this times this, and then combining your like terms. And if you combine all your like terms, you end up with this. I had my finger right there, but that is a capital A, b squared cosine a squared. All right, that's a lot going on in this line right here, so we're going to try and clean that up. We're going to try and simplify it a little bit. And the first thing I'm going to do is factor out a b squared from this first term. We have 1, 2, 3, 4 terms. All right, we've got b squared sine squared a is one term, plus another term, c squared, minus another term, all this plus this last term. So 4 terms. 2 of those 4 terms have a b squared in it, the first one and the last one. So I'm just looking at my first term and my last term that both have a b squared in it, and I'm going to pull that b squared out. That'd be just like saying if I had 3x plus 12y, I have 2 terms where I can pull out a 3 in both terms. That would be 3x plus 4y. That's what I'm doing with these first and last terms. I have a b squared in both those terms. So I pull out a b squared from here, and I'm left with sine a squared. I pull out a b squared from here, and I'm left with cosine a squared. So I get b squared times this whole parenthesis. That simplifies my first and my last term. Then my middle 2 terms I haven't touched. It's still plus c squared minus 2cb cosine a. All right, now this is where the trig identity comes in that I showed you earlier. Sine squared a plus cosine squared a is equal to 1, and anything times 1 is just itself. So b squared times all this is just b squared. And I haven't touched the c squared. I haven't touched the minus 2cb cosine a. All I did was switch the b and the c, because 3 times 4 is the same thing as 4 times 3. You know, when you multiply, it doesn't matter the order. So I switched the order of those 2, and there you go. A squared equals b squared plus c squared minus 2bc cosine a. That is the law of cosines. That is the formula that I showed you in the other video that you need to substitute in numbers for b, c, and angle A to solve for side A, and that's what the work for today is like. So the work for today, you're just using this formula and substituting in 3 numbers. Side B, side C, side B and side C again, and angle A, and then you can do the math and solve for A, side A, and that's what the other video explains how to do. So in the other video I started here, and that's all you really need to know. But in this video I explained how to get there. If you understand that, then you're a borderline genius, because I know you're all very smart, but you're still only 14 years old. Your brain still has plenty of room to grow and mature, and calculus isn't really something that 14-year-olds should understand. So if you understood that, congratulations, you're smarter than me.